Okay, so welcome back. So now we're going to do this example here. So the interesting thing here is we have a cosine n, so we have a trig function. So the one thing to note is the behavior of the absolute value, or well, the behavior of cosine in general, right? So we know cosine goes between 0 and -1 and 1. Okay, so we note, right, we know that the absolute value of cosine n is less than or equal to 1. So if we use the absolute value, so if we look at the absolute value of the series, right, then we know that this is going to be what? Less than or equal to one over n squared. And so we can use the comparison test to see what this, now this converges, right? So by the comparison test, we know that this converges as well. Why? Because we know that for all values of n greater than or equal to 1, right? We know that the absolute value of cosine n over n squared is less than or equal to 1 over n squared. For all n greater than or equal to 1. And we know that this converges. So since this nth term is always less than or equal to this nth term, right? And the fact that this converges leads us to believe that, again, the sequence of partial sums here converges, and of course by the comparison test, this also converges. So again, by the comparison test, the series of absolute value of cosine n over n squared converges. And hence, by the theorem that we went over, the series from 1 to infinity of cosine, cosine n over n squared converges absolutely. And that's it. Have a great day.